Install Instio. So use an Alibaba Cloud Container Service Kubernetes cluster as an example here. Now Alibaba Cloud Container Service has enabled the initializer plugin by default for Kubernetes clusters. If the cluster version is later than 1.8, no other configurations are needed. Now you need to note that after you deploy the Istio, a sidecar is injected to each pod to take over the service communication. Therefore, we recommend that you verify this in the independent test environment. Now, creating Kubernetes cluster. Log on to the Container Service console. Click Kubernetes in the left side navigation pane as you can see on the screen. Click Create Kubernetes Cluster in the upper right corner. Configure the parameters to create a cluster. For how to create a Kubernetes cluster, we can refer the section wherein we discuss how to create a cluster. After the cluster is created, click Manage at the right of the cluster when the cluster status is changed to running, as you can see on the screen. Now on the cluster basic information page, you can configure the corresponding connections information based on the page information. You can connect to the cluster either by using kube control command or SSH, as you can see on the screen. Now deploy Istio release version. Now log on to the master node and run the following command to get the latest Istio installation package. As you can see on the screen, run the following command. Again, you can refer that on the screen and run the following command to deploy Istio, as you can see again. Now after the deployment, run the following command to verify if the Istio component are successfully deployed. As you can see on the screen, you can check it over. Now after all the pods are in the running status, the Istio deployment is finished. Okay, now coming on to Istio distributed service tracking case. Now deploy and test the application Book Info. Book Info is an application similar to an online bookstore, which is composed of several independent microservices compiled by different languages. Now the application Book Info is deployed in the container mode and does not have any dependencies on Istio. All the microservices are packaged together with an Envoy sidecar. The Envoy sidecar intercepts the inbound and outbound call requests of services to demonstrate the distributed tracking function of Istio service mesh. As you can see on the screen in the figure which you are getting on the screen. Now run the following command to deploy and test the application Book Info. As you can see on the screen, in the Alibaba Cloud Kubernetes cluster environment, every cluster has been configured with the server load balancer and ingress. Run the following command to obtain the IP address of ingress, as you can see at the bottom of the screen now. Now, if the preceding command cannot obtain the external IP address, run the following command to obtain the corresponding address. Again, you can see the command on the screen. The application is successfully deployed if the following command returns 200. You can open HTTP gateway URL product page in the browser to access the application. Gateway URL is the IP address of ingress. And the details you can see on the screen. Okay, now deploy Jagger tracking system. Distributed tracking system helps you observe the call chain between services and is useful when diagnosing performance issues and analyzing system failures. Istio ecology supports different distributed tracking systems including Zipkin and Jaeger. Let's use the Jaeger as an example. Istio version 0.4 supports Jaeger. The test method is as follows, as you can see on the screen. After the deployment is finished, if you connect to the Kubernetes cluster by using cube control command, run the following command to access the Jaeger control panel by using port mapping and open, which is again using the command http localhost 16686 in the browser, and you can see the command on the screen. If you connect to the Alibaba Cloud Kubernetes cluster by using SSH, run the following command to check the external access address of Jaeger query service. Record the external access IP address and port of Jaeger query and then open the application in the browser. By accessing the application book info for multiple times and generating the call chain information, we can view the call chain information of service clearly, as you can see on the screen. Now click a specific trace to view the details. You can also view DAG. Now, as visible on the screen. It's self-explanatory, so I'm not taking too much of time explaining this. Now, let's cover a bit about implementation principle of ISTO distributed tracking. Now, the kernel of ISTO service mesh is the Envoy, which is high performance and open source layer 7 proxy and communication bus. In ISTO, each microservice is injected with an Envoy sidecar, and this instance is responsible for processing all the inbound and outbound network traffic. Therefore, each Envoy sidecar can monitor all the API calls between services, record the time required by each service call, and record whether each service call is successful or not. Now, whenever a microservice initiates an external call, the client Envoy will create a new span. A span represents the complete interaction process between a collection of microservices starting from a caller, which is client, and sending a request to receiving the response from the server. In the service interaction process, client record the request start time and response receipt time, and the Envoy on the server record the request receipt time and response return time. Each Envoy distributes their own span view information to the distributed tracking system. When a microservice processes request, other microservices might need to be called, which causes the creation of a casually related span and then form the complete trace. Then an application must be used to collect and forward the following headers from the requested image. Okay, so these headers are like, X request ID, XB3 trace ID, then span ID, parent span ID, sampled, flags, span context, as you can see on the screen. Envoys in the communication links can intercept, process, and forward the corresponding headers. Let's conclude it a bit. For more detail, you can refer the resource which I would be attaching of the ISTO document. Let's conclude it a bit. ISTO is accelerating the application and popularization of service mesh by using the good expansion mechanism and strong ecology. In addition to those mentioned in the preceding section, we have scope, ISTO dashboard, and ISTO analytics projects provide abundant call link visualization and analysis capabilities. Okay, so with this I'm taking a pause, and in the next lecture we would be continuing with this best practices, and we would be discussing about SWAM. Thank you very much.